to the Fundamentals of Electricity course. In this course, we'll cover the basics in electrical understanding that can be applied to circuits used every day in transmission diagnosis. My name is Lance Wiggins. I'll be your host. It's a great day to fix transmissions, so let's get started. For electricity to flow, we need to provide a conductive path from negative to positive. This path is called a circuit. And while there are several different types of circuits, all of them have a few things in common. In this case, what we're showing to you here is a battery, a fuse, your switch, and your bulb. This would be your component. Your battery supplies voltage to the switch, turn the switch from on to off, supplies voltage to the bulb, and of course you have a negative side of your component. Kirchhoff's law of voltage. Voltage drop in a circuit will increase proportionally with resistance. When added together, the sum of the voltage drops in a circuit will equal the voltage drop of the entire circuit. There will be almost no voltage left over. How do we determine what voltage and resistance and amperage is in a system when we don't have the specifications? The laws of voltage allow us to do this. Just place your finger over any one of the sections, and what's left is a formula for Ohm's law. That defines the characteristic you've covered. So let's take a look at that real quick as we look at this. So this would be what we would consider division, the division line right here. That's the division line. This would be considered the multiplication line. So if we take, as this example, if you cover the E, which is our voltage, you're left with I and R. I is your amperage, R is your resistance. You take your I, multiply that by R, it equals E. So in this case, if we had 0.7 amps, we multiplied that by 20 ohms of resistance, we're roughly going to be using about 14 volts. Conversely, if you cover the I, now we're covering the current, you're left with E over R. So there's where your division line comes in. So in this case, we're going to take the E, which is voltage, we're going to divide that by the resistance, and that'll give us our amperage being used. So in this case, we'll use 14 volts divided by 20 ohm resistance, and it's going to give us our 0.7. Notice we had our 0.7 up here too, so that means our math is good. If you cover the resistance, you're left with E over I. So to calculate the ohms, you just simply divide your voltage, which is your E, divide that by I, which is your amperage, and that'll give you your resistance. So in this case, we're taking 14 volts, divide it by 0.7 amps, and that gives us 20 ohms of resistance. So either way, if you're having trouble with the specifications, this gives you a great way to test that. All right, let's take a look at a series circuit here. We'll cover the basic series circuits in this example that are commonly used in transmission diagnostics. Keep in mind there will be many other types of electrical circuits, such as parallel circuits and parallel series circuits, and many more. The most familiar type of the circuits are series circuits. Would be a simple string of Christmas lights. So in this case, here we have our battery positive connected to a positive lead going up to one light, through a resistor, through a resistor, through a resistor, and back to ground.